Hello, hello, hello. So let's discuss the solution to the blinking insects. The flicker that you could see. I took that video at night when it was about 10 p.m. near the end of July. Now you see the same image during the day. I just woke up and I turned that outside light on, so I'll show you where that outside light is located. Look, this is a nice flower. Oh boy, there is that outside light. If I go straight into it, it will probably blast. Very bright. It's about 300 watts. I will turn it off so that you can see the size of that light. Oh, you can see me standing in pyjama in the reflection. Okay, so I'll turn the light now off and then show it to you again. Okay, so there you see the light again. Now it's off. This light goes on and off, well, maybe not exactly off, 120 times per second, because it's driven by 60 Hertz AC, alternating current. And that means 120 times per second the current is zero. It goes from plus 120 volts to minus 120 volts in the United States and then back to 120 volts. And that happens in 1/60th of a second. And so it twice goes through zero in 1/60th of a second. So it goes 120 times on and off per second. 120 Hertz. So let's now work on my blackboard, and then you will clearly understand, of course, that the flickering that you saw when the insects were flying was the result of this light flickering. Nothing, the insects did nothing, but the light went on and off, or almost off, 120 times per second. So we'll do a few simple calculations. You ready? I'm ready. So here you see the kind of light that I have outside. It's an halogen incandescent light. The length of this light bulb, although it's not a bulb, well, could be easily 15 centimeters. This is 150 watts. Cost $3.29. The one I have outside is 300 watts. Light is very bright. They get extremely hot because it's incandescent. Alright, so there is no doubt that the flickering, the blinking in the tracks of these insects is due to the 60 Hz AC of my light source. And so whenever the voltage is plus 120 or minus 120, there is maximum light. So that happens 120 times per second. Now, how bright the maximum is compared to the minimum, that is not so easy to predict. Clearly, it all depends on the cooling time of the filaments. It is an incandescent bulb, and so don't think that there is zero light ever. But there should be at least 2 points in the track that are the brightest, and that's probably near the 120 volts plus and the 120 volts minus. If you stop the video, you can look at individual images. These images is an integration of my recorder, my video recorder. And the exposure time is probably somewhere between 1/20th of a second or 1/25th of a second. It may not even be constant because my camera is a rather cheap one, but it is somewhere there. So that means that if an insect has flown for about 1/25th of a second, which is the exposure time, then you would see 5 flashes, roughly. 5 times would the light be a maximum. If it's 1/20th of a second, you may see 6 bright flashes. So this is just to give you a rough idea. Now, these insects typically fly 1 meter per second. Could be 2 times less, could be a little more, but I will just hold on to roughly 1 meter per second, because all I want to do is to give you just a rough idea of what you're looking at. In 1/120th of a second, the insect would then have flown about 8 millimeters. Now, would that be 8 millimeters in the projection of my camera? Not at all. That depends on the orientation of the trajectory. If the object, the insect, flies straight to my camera lens, then of course you wouldn't see any blinks. You would just see a point. And so the length of the tracks during the exposure time of my camera will differ depending upon the direction that the insect is flying. Here you see 4 insects during this exposure. If we count the number of flashes, bright flashes, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is a faint one. 1, 2, 3, 4, 5. So we can hold on to the 5 flashes. And if this insect were flying at a 90-degree angle relative to the direction of my camera, then this would be roughly from here to here about 3 centimeters. And from here to here would then be about 0.8 centimeters. What is very interesting, that at maximum light you see structure. Look here. This is brighter than that. This is brighter than that. But clearly there were 1, 2, 3, 4, 5 flashes. That's clear. So this gives you information about the size of the insect from which the light reflects. The insect could be larger than that size, but that's the size that has the maximum reflection. And how large this will be depends again also on the orientation of the insect relative to the direction in which I view with my recorder. So if from here to here is about 0.8 centimeters, then this here, from here to there, is about 3 millimeters. And also here should be roughly 3 millimeters. This track is shorter. Well, that could be due to projection effect, of course. But the distance here, which is probably, the insect is probably flying close to 90-degree angle to my direction, that 3 millimeters must tell us something about the size of the insect. It may interest you that most of the flies that we have here as a pain in the neck are black flies. They have a size of about 3 millimeters. But mosquitoes, for instance, we also have many of those, are much larger than 3 millimeters. But there is no doubt in my mind that what you see here is effectively an indication of the size of the insect that is reflecting to you. You see that remarkably well here. This is another picture when I stopped my video camera. It's clear that there is 1, 2, 3, 4, 5, maybe 6 flashes. And again, the insect has definitely 2 parts from which it reflects a lot of light. What is also interesting, if you look here, it looks reddish. Well, there's no need to assume that they couldn't be reddish, those insects. So let's take a look at my last stop. This one is very interesting. So this one is probably flying 90 degrees angles to us. This one is also close to that. Here you don't see any clear finite size of the insect. Well, that could depend on its orientation. It could also be due to the fact that this insect has only one reflecting part of its body. I think it's more likely that it has to do with the orientation relative to which it is flying. This case is very interesting. You notice red here, red here, red here, red here. And that is during the times that there is certainly not maximum light. It would be clear that the maximum light is here, 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 and there. And it was there. So I cannot add much more to all this. The goal was to explain the flickering and the blinking. There is zero doubt that that's the result of the 60 Hz AC. But what is so nice, that if you stop the video, that you get information on the individual insects. And you may even be able to conclude that there are many different insects. But that was not the objective of this problem, which I want to remind you is the Midsummer Night's problem. Midsummer Night's Dream, which I borrowed from Shakespeare. And this is my next Midsummer Night's problem. Definitely the last one this academic season during vacation. My next problem will be posted roughly near mid-September. Okay, enjoy the rest of your vacation. And what I would advise you to do is stop the video of the problem as often as you can. You will see remarkable things. You will even see a large butterfly at one point. So go back to the problem, which I posted maybe 10 days ago, and then stop the problem video. Stop it 20 times. Maybe you will see things that I missed. Okay, enjoy the rest of your vacation. Take care, and if at all possible, try to be friends with me, because I would like to be friends with you.